Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. We are discussing hybridization of the molecules. In the previous video, we have discussed hybridization of some molecules. Now, another molecule. Some molecules are there, some more molecules are there for discussing hybridization. Now, another molecule is that H2O. H2O. In H2O, the central atom is oxygen and hybrid oxygen, and it belongs to 6th group. 6th group means it contains 6 valence electrons. 1, 2, 3, 4, 5, 6. 6 valence electrons. Oxygen is forming 2 bonds with 2 hydrogen atoms. 1, 2. And remaining 4 electrons. Exist as 2 lone pairs. Now bond pairs. How many bond pairs? 2 bond pairs and 2 lone pairs. 1, 2. 2 lone pairs. So steric number. Steric number means total number of bond pairs and lone pairs is called steric number. 2 plus 2, 4. If the steric number is 4, the hybridization should be sp3. Hybridization should be sp3. And when we observe the structure, the central atom is oxygen and it is forming 2 bonds with 2 hydrogen atoms, and central atom has 2 lone pairs. So 2 bond pairs and 2 lone pairs. And the bond angle is 104.5 degrees. The shape, it has bent shape or V shape or angular shape. So bent shape or V shape or angular shape, we can say any name. Also, we discussed SO2. SO2 has 2 bond pairs. 2 bond pairs, lone pair 1. So SO2 also has bent shape. It has one lone pair. It has 1 lone pair. If it has 2 bond pairs, 1 lone pair, in that time it also has a bent shape. If any molecule has 2 bond pairs and 2 lone pairs, the shape is bent shape. And also if the molecule has 2 bond pairs and 1 lone pair, in that time the molecule should be in bent shape. Now next molecule. Here H2O molecule is AB2E2. It belongs to AB2E2 molecule. So that means H2O molecule has 2 bond pairs and 2 electron pairs. How many electron pairs? Nothing but lone pair. How many lone pairs? 2 lone pairs. Thus we can write AB2E2. H2O belongs to AB2E2. So next molecule, PCl5, phosphorus pentachloride. Phosphorus pentachloride. The central atom is phosphorus. It belongs to 5th group element, and that means it contains 5 valence electrons. First write 5 valence electrons, and phosphorus is forming 5 bonds with 5 chlorine atoms. 1, 2, 3, 4, 5 bonds. That means 5 bond pairs. So bond pairs 5, and there is no lone pairs, 0. And the steric number 5 plus 0, 5. If the steric number is 5, the hybridization should be sp3d. So 1 plus 3, 4, 4 plus 1, 5. If the steric number is 5, the hybridization should be sp3d. And when we observe the structure, the central atom is phosphorus. In PCl5 structure, when we observe the PCl5 structure, it has 2 types of bonds. Equatorial bonds. 3 bonds exist as equatorial bonds. 3 bonds exist in equatorial. That means these 3 bonds exist in a same plane. same plane like horizontal, and the remaining two bonds. Here the bond angle between any two chlorine atom is 120 degrees, and the remaining two chlorine atom exist in vertical shape, vertical plane. These are called axial bonds, and the bond angle is 180 degrees. Okay, in PCl5 molecule, 3 chlorine atoms exist in equatorial position, that means these are same plane, and the remaining 2 chlorine bonds exist in axial position, So this is the shape trigonal bipyramidal. Trigonal bipyramidal shape. If any molecule has 5 bond pairs and 0 lone pairs, the molecule should be trigonal bipyramidal, and the hybridization is sp3d, and it belongs to AB5 molecule. That means it has 5 bond pairs. There is no lone pairs. So next molecule is SF4. In SF4, the central atom is sulfur, and it belongs to 6A group element. Sulfur belongs to 6A group element. It contains 6 valence electrons, and sulfur is forming 4 bonds with 4 fluorine atoms. Remaining 2 electrons exist as 1 lone pair. That means here how many bond pairs? 1, 2, 3, 4. 4 bond pairs, and lone pairs. There is 1 lone pair, and steric number 4 plus 1 5. Steric number is 5, and the hybridization should be sp3d. When we observe the structure, so sulfur is forming 4 bonds with 4 fluorine atoms, and it has 1 lone pair. The shape is seesaw. If any molecule has 4 bond pairs, 1 lone pair, the molecule should be exist in seesaw structure. Here it is belongs to AB4A. That means it contains 4 bond pairs, 1 electron pair, nothing but 1 lone pair. Next molecule, we go to next molecule. ClF3. In ClF3, the central atom is chlorine. It belongs to 7th A group element. That means it contains 7 valence electrons. And chlorine is forming 3 bonds with 3 fluorine atoms. And the remaining 4 electrons exist as 2 bond pairs. And here how many bond pairs? 1, 2, 3. 3 bond pairs. And how many lone pairs? 1, 2. 2 lone pairs. And the steric number is 3 plus 2. Steric number is 5. The hybridization, if the steric number is 5, the hybridization should be sp3d. When we observe the structure, the central atom is chlorine, and it forms 3 bonds with 3 fluorine atoms, and it has 2 lone pairs. The shape is T-shape. If any molecule has 3 bond pairs and 2 lone pairs, the molecule exists in T-shape. It has in this molecule in ClF3, how many bond pairs are there? 3 bond pairs. How many lone pairs? 2 lone pairs. And sometimes they will ask how many bond pairs present in ClF3 molecule. How many bond pairs present in central chlorine atom? How many lone pairs present in central chlorine atom? So they can ask like that. Next, it belongs to Ab3E2 molecule. Ab3E2 molecule. That means it has 3 bond pairs and 2 electron pairs. 3 bond pairs and 2 electron pairs. 2 electron pairs, nothing but 2 lone pairs. So next molecule is we go to next molecule. So XeF2. XeF2. The central atom is xenon. It belongs to 8th A group element or 0 group element. That means it contains 8 valency electrons. 8 valency electrons. Xenon is forming 2 bonds with 2 fluorine atoms, and the remaining 6 electrons exist in 3 lone pairs. Now bond pairs. So how many bond pairs? 2 bond pairs. How many lone pairs? 1, 2, 3. 3 lone pairs. Steric number 2 plus 3, 5. So it should be sp3d hybridization. sp3d hybridization. So when we observe the structure, xenon is forming 2 bonds with 2 fluorine atoms, and it has 3 lone pairs. It is a linear shape. It is a linear shape. Next, SF6. SF6 molecule. The central atom is sulfur. It belongs to 6th A group element. It contains 6 valence electrons. 6 valence electrons, and sulfur is forming 6 bonds with 6 fluorine atoms. Sulfur is forming 6 bonds with 6 fluorine atoms. And now, how many bond pairs? 1, 2, 3, 4, 5, 6. 6 bond pairs, and lone pairs 0. Steric number 6 plus 0, 6. If the steric number is 6, the hybridization should be sp3 d2. So s power 1, p power 3, d power 2. 1 plus 3, 4. 4 plus 2, 6. So if the steric number is 6, the hybridization should be sp3 d2. And when we see the structure, sulfur, central atom is sulfur. It also can form 2 types of bonds. First, 4 bonds in equatorial position, and the bond angle between any 2 fluorine atoms 90 degrees. And remaining 2 fluorine atoms exist in axial position, and the bond angle is 180 degrees. The bond angle is 180 degrees. Now, next molecule is, now we observe next molecule. And that is BRF5. In BRF5, the central atom is bromine, and it belongs to 7th A group element. It contains 7 valence electrons. 7 valence electrons, and bromine is forming 5 bonds with 5 fluorine atoms. Bromine is forming 5 bonds with 5 fluorine atoms, and the remaining 2 electrons exist as 1 lone pair. Now, this in BRF5, how many bond pairs? 5 bond pairs, and lone pairs 1 lone pair. Steric number equal to 5 plus 1, 6. If any molecule has steric number 6, the hybridization should be sp3 d2. So when we observe the structure, bromine is forming 5 bonds with 5 fluorine atoms. 4 bonds in equatorial position, and 1 bond in axial position, 1 lone pair in axial position. This is square pyramidal. Square pyramidal. In square pyramidal, okay, If any molecule has 5 bond pairs and 1 lone pair, the molecule should be in square pyramidal. So this molecule is in the form of AB5E. So 5 bond pairs, 1 electron pair. Except it belongs to AB2E3. AB2E3, that means except contains 2 bond pairs and 3 electron pairs, that means 3 lone pairs. SF6, it belongs to AB6 molecule, that means it contains only 6 bond pairs. So these are the molecules. In this way we can find out hybridization of the molecule and structure of the molecules. If it is useful to you, please like, share and subscribe my channel. Thanks to all for watching my video.